Hi, I'm Thomas. Welcome back. Our topic is differentiation. This is implicit differentiation, example 2. Our requirement reads, find the value of the derivative of y with respect to x at the point 1, 1, where 4xy squared plus 6x squared over y equals 10. Applying our algorithm, step 1, differentiate all terms with respect to x. And also noting step 2, anytime we see a function of y, we will use chain rule to differentiate f of y. Beginning with 4xy squared. We need to apply the product rule here. We're multiplying x times y squared. So we will have 4 times, and then I'll apply the product rule to the multiplication of our two functions. The derivative of x is 1 times the original function y squared plus the original function x times the derivative of y squared, which is 2y, and because this is a y function, we're going to apply the chain rule, which I've noted in the upper right corner of the screen. The derivative of the y function times dy over dx. Close brackets. On to our next term, 6x squared divided by y. I could use the quotient rule, but I'm going to change this so that I can use the product rule. This is the same as 6x squared times y to the power of negative 1. Our multiple is 6. Again, we're using the product rule. We're multiplying two functions, x squared times y to the power of negative 1. I'll start with the derivative of x squared, which is 2x, times the original second function, y to the power of negative 1, plus the original first function, x squared, times the derivative of the second function. The second function is y to the power of negative 1. The derivative is negative 1y to the power of negative 2. And again, because this is a y function, we'll apply the chain rule and now multiply this derivative by dy over dx, close brackets, equals 10. 10 is a constant. The derivative of a constant is 0. We've completed step 1, and notice that we've also applied in two cases step 2, chain rule to differentiate f of y. Step 3, make dy over dx subjective equation. Let's distribute the 4. 4 times 1 times y squared is 4y squared plus 4 times x times 2y times dy over dx plus 4 times 2 is 8xy times dy over dx plus, now distributing the 6, 6 times 2x times y to the power of negative 1. 6 times 2 is 12 times x times y to the power of negative 1 is the same as divide by y to the power of 1, or divide by y. Next term, 6 times x squared times negative y to the power of negative 2 times dy over dx. We'll have a negative 6x squared. With a multiplication of y to the power of negative 2, we'll put the y term in the denominator as y squared times dy over dx equals 0. On the left side of the equation, I'm going to keep the terms with dy over dx as a factor and move all other terms to the right side of the equation. So we will have 8xy times dy over dx minus 6x squared over y squared times dy over dx. And moving our other terms to the right side, 4y squared moved to the right will become negative 4y squared. And 12x over y moved to the right will become negative 12x over y. On the left, I'll factor out dy over dx from both terms. We have dy over dx times 8xy minus, in the second term, factoring out dy over dx, we're left with 6x squared over y squared equals, the right side stays the same, negative 4y squared minus 12x over y. And finally, we'll divide both sides by 8xy minus 6x squared over y squared. Again, 8xy minus 6x squared over y squared. We have cancellation on the left, and now we have dy over dx equals negative 4y squared minus 12x over y over 8xy minus 6x squared over y squared. Now from here, I'm not going to do any more algebraic simplification because the requirement is to find a particular value at a particular point. So moving on to step 4, from step 3, dy over dx equals, and now the right side of the equation, the right side of the result from step 3, in that expression, we'll replace all x values with 1 and all y values with 1. Those are the x and y coordinates of the point given in the requirement. So we have negative 4 times 1 squared minus 12 times 1 over 1. So in the numerator, I've replaced all x's with 1 and all y's with 1, divided by 8 times 1 times 1 minus 6 times 1 squared divided by 1 squared. Again, in the denominator, replacing all x's with 1 and all y's with 1. From here, we can simplify negative 4 times 1 squared is 1, times negative 4 is negative 4, minus 12 times 1 over 1 is minus 12, over 8 times 1 times 1, 8, minus 6 times 1 squared divided by 1 squared is minus 6. And this expression simplifies to negative 16 over positive 2, which is negative 8. So, the value of the derivative of y with respect to x at the point 1, 1, given the particular function, is negative 8. We've completed all requirements, and this concludes implicit differentiation example 2.